Hi, I'm Joe Savona. I work on the product infrastructure team at Facebook, along with Lee and Spencer and many others from Facebook who are here today. And I'm here today to talk about Relay. So Relay is a framework that we developed at Facebook to manage data in client applications. So I don't have speaker notes, so I'm going to do this live. So really, in order to understand what Relay is, it's helpful to go back in time a year ago and think about how we were doing client-side development on the web and also for native. Wow, I really don't have speaker notes. This is going to be great. Okay, give me a moment. Give me a moment.
Let's put speaker notes again.
Wait, I just need wise, like.
Sorry for the interruption.
Sorry. It's fine. I'll just do it. It's fine.
Il manque les speaker notes. Okay.
It's fine. I'll just do it.
Okay. Well,
it's fine. All right, we're gonna do it. It's all good. Yeah, I can't get to the display settings. I don't know why. There's no mirroring though.
arrangements.
God damn it. Oh, all right. That's much better. Okay. And the main display is the wrong one? Yeah, okay. That's much better. All right. Now you can actually learn about Relay instead of hearing me ad-libs and stuff. All right. So now we're all good. All right. So thank you for your patience. Sorry about that. Okay, going back in time a year ago, thinking about how we developed client-side applications. So obviously at Facebook, developers have a choice of the technologies they use, but developers were choosing to use React. And you're all here at ReactConf, you understand why, right? React makes it a lot easier to do client-side development. It's a simpler mental model. We can think about components in isolation instead of having to reason about the entire system at once. It's also a lot easier to think about views when we just return a render function, right? It's just declarative. We just return what should happen, and then React actually takes care of updating the DOM for us. The top-down data flow makes it really easy to reason about the state of our application at any given time. And Flux complements React, again, by providing a consistent architecture for handling data change over time. So you're all familiar with this, with this architecture. Obviously, Dan just talked about a lot of these ideas. Great talk, by the way, Dan. But there's one piece that was missing, right? Like React and Flux are really great, and they continue to work really well for our developers, but there is a missing piece. And that missing piece is how to get data to and from the server. And this doesn't seem like it would be a big deal, but it actually turns out to be the source of significant friction for our developers. So let's think about what was involved in this process. So we're going to take this imaginary app that, wouldn't it be cool if somebody made an app like this where I could post photos and my friends could comment on them? Wait, we did that. We're React developers, we're UI developers, we see this and we're like, I see components. So let's just get them out of the way. There's a feed, right? And the feed is going to represent the list of photos. We'll have a media component that represents an individual photo with the header, the image, and the comments. And then a comment component for each individual comment. Now, obviously, there's like a couple levels that you might choose to add, like a comment list, or you might choose to have a header. Well, we'll just focus on these three components for now. So now the question is, this mock-up looks pretty simple. We've got our components. It should be really easy to build this application, right? I mean, it's 3 components. How hard could it be? But you all know that the answer to that question is that it's actually really hard because the data has to come from somewhere, and that's when you say, oh, what do I do now? So there's a bunch of options, right? Again, we're developers, we can solve this. So I'll kind of talk about a couple different options here, and these might seem a little bit extreme, but they're kind of to illustrate the point. So please don't react and say that I'm actually suggesting that any of these should be done exactly as is. The first, you might say, well, let's not duplicate our logic on the server. Let's try to keep, as much as possible, each endpoint distinct. So we might do something like this, a feed endpoint that returns a list of photo IDs that should be rendered. And then the application can go and fetch information about each of those photos given the ID from a photo endpoint. Of course, the photo endpoint returns a list of comment IDs, and so the application has to go and fetch the actual comment information. Okay, so that's a lot of round trips. That's really not, maybe it'll work on desktop if you've got a really high bandwidth connection, but on a mobile device with a slow network, it's really not gonna be great. So developer experience-wise, okay, it's easy enough, we'll just hit distinct endpoints. But the user experience, we get something like this. We see a loading screen, we see the first photo, but the comments are still there, spinners, lots of spinners. And then you see here, okay, things start to break down because the third photo arrived before the second one did. That's not, wait, would you expect that? And then when the second photo comes in, things are gonna shift around on the screen, so if I'm scrolling, that's gonna be kind of janky. This is really not great, right? Okay, so that's not so cool. Let's try something else. We'll just do the total opposite. We'll have one custom endpoint that returns all the data we need for the entire application. Like, it couldn't be any simpler, right? Feed with photos and comments. We're done. Go home. Like, excellent, right? Just ship it. Except you get this. Loading, loading, still loading. Oh, look, it's an app. And the user's already gone. So clearly, this is, again, not probably a reasonable approach. In the end, we probably all do something like this, multiple custom endpoints. And the way that we might do that for this application would be, let's say, a feed, again, that feed endpoint, but we'll modify it this time. And the feed will return all of the information for the media component. So the header information, the photo, as well as the comments and the author information. And we can specify exactly how many photos we want to fetch. But in order not to wait for all three, we'll make separate fetches for the first item, the second item, the third item. Now we've got a really great user experience. The first photo loads in, the second photo loads in, the third photo loads in, and the user can just keep on scrolling through. All right, so we've kind of made a bit of a trade-off, right? We've got some duplication of possibly some duplication of our server logic because we're fetching the comments and the photos all in one endpoint. We might need to fetch that information somewhere else. But the user experience is pretty good. But we all know we're not done. Yeah, so there's edge cases. As with everything, we actually got to coordinate the requests. We've got to write imperative logic that makes sure that we fetch these things, these endpoints in the correct order. So regardless of which approach we've chosen, whether it's the initial approach with reusable endpoints or one custom endpoint or multiple custom endpoints, we have to write logic to manage that data fetching and think about how our local state is changing over time. So local state changing over time, we've seen that before, right? In the DOM with events. So this should start to feel familiar. But there's even more edge cases to consider, right? We don't want the third photo to load before the second one. That's going to be hard to do, but we'll figure out some way to do that. What if a new photo is taken? So I load photos 1, 2, and 3, then I go to scroll, but there's a new photo at the top, so now 1 is at 2, 2 is at 3, oops, sorry, everyone, sorry. I'm Italian, I talk with my hands. 3 becomes 4, and now when I scroll, the third photo is at 4, and I see the same photo twice in a row. So clearly, pagination is not going to be as simple as just fetching another item. There's actually a lot of logic that's going to have to go into it. Then you get into things like the Facebook newsfeed, where it's algorithmic ranking, and things can jump around in the feed, and things get even more complicated. And not to mention error handling, retries, timeouts, all that stuff. Okay. All right, but we're like a month later, and the simple app is like maybe kind of done, but things don't stay the same, right? We actually develop our apps and move on. So this is a simple example of the comment component. It's kind of starting at the simplest case. And it's really simple, right? Just the author's name and the text of the comment. Pretty easy. Now, a designer might come along and say, we want to show the photo of the author. Right? We just like see if that increases engagement, see if people like enjoy the app more. Now, again, we're all React developers, right? So we see this and we think, okay, easy, we'll just add an image. And it really is just that easy to make the change. Or is it? That information has to come from somewhere, as we all know. So, here's our app, here's our endpoint. I'm just going to highlight the particular parts of the application that are going to be affected by this small change. I'll just highlight only those parts in red. Yeah, so it's really not that simple, right? Because the media component gives data to the comment component, and the feed passes data to the media component. And of course, the endpoint actually fetches the data that goes into all this. Right. So our simple change has turned into this. And what this means is, that comment component might be used in other places in the app. There might be other endpoints that fetch data for it. And so this one change requires a cascade of changes throughout our application. So if you're a new developer coming into this, and you get a task that says, add this photo, you might think it starts off really easily, but then that new developer has to figure out pretty much the entire system in order to make this one change. So this really doesn't scale. Yeah. But of course, apps wouldn't be very interesting if we couldn't write data to them, right? Obviously, we've got to actually put some data into the system. And writes are even more complicated than reads. So there's a lot of different cases that can happen here. If the user posts 2 comments in quick succession, what happens if one of them what if it happens if the second one arrives at the server first, right? Or if the responses arrive back from the server out of order, how do we ensure that those comments are actually visible to the user in the correct order? What happens if the user posts 2 comments, but the first one fails for some reason? Just the network request doesn't go through. Not even getting into authentication, authorization, all those things. So we're going to handle those cases too. What if the server response just simply takes a really long time? How do we let the user know that that request is still pending and it hasn't just simply failed? Do we show pending comments to the user? So if I type something in and hit enter, do we show the user that it's pending, or do we just show nothing at all? What if someone else comments on that same photo while I'm commenting on it? I write a comment, you write a comment, I write another comment. How do we make sure those comments appear to the user in the correct order, to both users in particular? There's a lot of challenges to getting this right. Okay, so this is insane. Developers were spending a lot of time rewriting all of these things, these complex pieces of logic that had to be right or else the application would break. It was really easy to miss an edge case, to forget to add some data to one particular endpoint, and now a view somewhere is breaking. And of course, as I mentioned, for new developers, it's really hard to jump into the system and begin making changes, being productive, and having the confidence that the application is still going to work. So this is why we built Relay, to make it easier for product developers to focus on products and not on these repetitive, error-prone pieces of logic. And the first insight, Lee already mentioned in his talk on GraphQL, but the key is that what we're doing here, all of these approaches that we've discussed, they couple the server endpoints to our render logic, right? So this fragile coupling means it's a lot easier to break our application. The solution is pretty clear. Clients know exactly what data they need. It's implicit in the render function. When I say this.props.author.photo, I know I need that information. The client knows what it needs. So we just have to build a system that allows the client to express that and to drive the data fetching process. But we already have this great unit of encapsulation, the React component, right? We've all seen how powerful these declarative components are for handling views. And the solution was to add a declarative description of the component's needs inside the component. And we use, obviously, GraphQL to do this. So we talked about this before. Let's look at how this actually works in code. So we'll start at the bottom of the application with the simplest component, the comment. Now, Lee already gave a demonstration of GraphQL, so I'm just not going to touch on that too much, but I'll just show an example of a GraphQL query. So we've all seen we wanted the comment component accesses the text of the comment and the author's name and photo. And so the GraphQL query expresses that exact structure. And I've shown a sample response below. Again, just plain JavaScript exactly matching that shape. So now let's consider how we would actually implement this in Relay. So you can see at the top of this file is the comment component that we already wrote before. I've collapsed it because it doesn't have to change. It stays exactly the same as it was. Instead of actually returning that to the application and directly using the comment, with Relay, we'll create a container for that comment component. And these containers are just basically higher order components. They're regular React components that you don't have to know how they work inside. They do the complex work for you and give your regular comment component props that are just plain objects, plain arrays, plain JavaScript objects. No new API to learn. You just get the same props you had before. Really just make sure the data is available for you. So remember, our comment component accessed this.props.comment. And so here we're defining queries.comment. So the results of this GraphQL query will be provided to the comment component as props.comment. So it's exactly one-to-one correspondence between the props that we access in our component and the queries that we define here. So if you're not familiar with higher order components and or containers, kind of two names for the same thing. And the way it works is our regular comment component expects to receive some props. But that would require us to actually fetch the data and make that and provide those props to the component. So instead, we can wrap that. This relay container wraps that component and says regular React component receives props, for example, a comment ID. And it will go and fetch the data for that comment and take the results of that query and make it available to our comment component. So if you're more mathematically minded, you might choose to think of it as functions. If you're a functional programmer, as Dan talked about, it's a lot that we can all learn from functional programming. So our regular components are really just a function over the props. And with Relay, we're just extending that, and we're kind of annotating those props and kind of adding extra value to them, taking the comment that you wanted to reference and returning the specific data for it. So we've talked about so far how to handle a single component. But of course, our applications are built of multiple layers of components. For example, the media component composes comments, right? So here's a really, really basic version of the media component. And we could all argue about my style of writing React components. I would probably rewrite this one if I had to. But it'll do for the sake of presentation. So we're looking at the media.comments property. And for each comment, this component will return a comment item for that comment. OK, so again, what we're doing here is composition. And Relay and GraphQL fully support a composition of queries and components as well. So the way that would work in Relay is, again, collapsing that media component basically stays the same, and wrapping it in a new container. Again, the component accessed this.props.queries, and so we'll provide, props.media, and so here we're defining queries.media. And for whatever media item we're looking at, this component is going to fetch the first 10 comments. And remember, this is GraphQL, so connections are edges. There might be information about the relationship, and so we actually have to look at the edge and look at the node at the other end of it. And for each comment, this component will fetch whatever information is required by the comment component. So there's a really interesting property here. Before, we saw that changing the comment component required us to change every part of our application. With Relay, we don't have to do that. The component drives its own data fetching. So a change to comment component won't require any changes to media at all. Adding a new property, we refresh the view, and the new query that's composed will contain all of the information required by the comment. So we can quickly make changes, adding a property to our query, adding a property to our view, and all of the information will just simply be there. Now, you may have noticed also that I didn't add any logic to handle the case for data that's not already available, right? Our components just sort of assume that the prop is somehow there. And that's an important design decision in Relay. Developers shouldn't have to worry about complex logic to handle what data is available, what data isn't available. By default, we just want all of our data to be available when we render. So Relay maintains that invariant. It's going to fetch all of our required data before ever rendering our components. So we just access the data. That's it. To see how that works in practice, we'll take a single component. But you can imagine this is the top level component, and of course it might compose many other components as well. So Relay extracts that component statically without ever having to render the component. Sends it to the server, gets the response back, and then can provide props to each of the views. Now, the props that are provided to each view are only the exact information that's requested by each component. So if you have two components that are both looking at the same comment, and they ask for different sets of data, they'll each only see the part they specifically asked for. So you can't have some other part of your application change and break a different view. Each component is completely isolated. But we talked about the whole, if you fetch everything in one custom endpoint, this looks a lot like the one custom endpoint solution, right? And we saw the problem was a really long loading spinner, which we don't want. So Relay wouldn't really be useful if it didn't allow us to specify that not all of our data is actually required up front. But of course, we still want to take advantage of efficient networking as much as possible. We don't really want to try to make too many round trips if we can avoid it, but we do need to kind of, at some points, delay loading. So I've refactored the media component. I've just put all those comments inside of a comment list component. we'll just pass media.comments to it. This makes it a little bit easier to think about how, instead of having to worry about the loop just here. It just kind of cleans up the code. Now, with a normal system, we would have to imperatively specify that the actual comments should be fetched separately, and we don't need them right away, right? And if we did that, our component would have to handle the case for what if the comments aren't available? What if we haven't fetched that yet? So here, we'll add an if statement. If the media.comments is fetched, if it's available, we'll render the comment list. If not, we'll render a spinner. Simple, right? Again, we don't have to actually think about what's happening, like all the asynchronous stuff that's happening. We just think about, given the data we have right now, what's been fetched, what do we render? Really easy to think about. Now, all we have to do is tell Relay which information is actually required and which information can be delayed and put off until fetched later. And we can do that with a simple annotation, defer. Again, we're not actually implementing the custom logic to make this happen. That Relay handles all of that for us. We just tell Relay, this is a description of what we need, and we're also annotating it with what is the priority of that information. And defer says, this isn't required. So now, when we render this component, we see an initial loading spinner. This is handled by Relay. When the information, the required information, is available, Relay will render our component. But of course, the comments aren't available yet, so we see a spinner. And then eventually, when that deferred data becomes available, Relay will update our component and show that information. So, Relay or any kind of data fetching framework wouldn't be useful if it didn't support writes. My colleague Lainey Kunzel gave a great talk at JSConf this year about how Relay handles writes. So if you're really interested in this topic, I would encourage you to go look up that talk. I'm just going to briefly touch on how writes are handled in Relay today. So again, Relay was designed from the start with a consistent architecture. It's based on the Flux model for handling writes and reads. Writes work where an action comes in from somewhere else in the system, typically in response to a user interaction. That's sent to Relay. Relay passes that information up to the server. It actually does a lot of things here. It ensures that after the write, we're going to have all the information that possibly could have changed as a result of it, but it's not going to overfetch and fetch anything we don't care about. So Relay does a lot of work behind the scenes to ensure that we update our local view of the world, but without having to fetch lots of extra information that the user doesn't care about. As a result of fetching that information, Relay updates its local store and provides updated props to components. Now, obviously, GraphQL pretty much implies it's a graph, right? Our data is actually a graph. There are cyclic references. So for example, I might post a story, like it, and also like one of the comments. I might write a comment on it. So if you look at the actual data for that, there's a lot of different paths that lead back to the same object, as you can see here. But our component tree, when we render, our component tree has 3 different instances of media. We've got a comment over there. The question is, how do we actually update this tree given that something in the graph changed? How do we know what changed? With Flux, the developer has to manually specify which components are listening to what data and actually manage that subscription. Subscribe when the component loads, unsubscribe when the component is unmounted. Relay automates all of that for developers. And Relay knows exactly what data is actually being referenced by each component. So when a change occurs, either we've fetched new information or a mutation action happens, Relay can automatically update only the components that are actually affected without the user having to do anything. And as you can see, media updated, but comment didn't. If the change doesn't affect the comment component, Relay implements should component update by default and knows whether that component actually needs to update itself or not. And so Relay can make changes really efficient. So what is Relay? There's a lot of different pieces, right? There's data collocation, we're using GraphQL. I find it really helpful to think about Relay in terms of what developers had to think about before and what they think about when they're using Relay. What you had to think about before was how to do a lot of things. How to actually fetch the data, how to coordinate reads and writes, right? We saw that that coordination is actually quite complex. How to handle retries, errors, failures, keeping a local cache of data in sync with the server, right? Cache invalidation is, as we all know, a pretty hard problem. And so once you get all of that in your head, you can actually then get back to focusing on your app, right? But we're here because we like building things. We're UI developers. The reason we're using React is that we want to build products. And Relay lets us do that. Relay says we specify what data to fetch and what order to fetch it in, not how to actually go about implementing all of that fetching. It means that product developers are able to focus on their products and not on repeating all of that error-prone logic. In particular, a lot of the complexity in data fetching comes from the fact that ultimately it's an asynchronous problem. Client, network, server. There's simply no way to get around the fact that the problem is asynchronous. UI development is async, and that's all there is to it. And there are a lot of great APIs for working with asynchronicity, right? You can use callbacks, you can use promises, observables are really great. And actually, we use all of these things inside of Relay. We use callbacks, we use promises, and we use observables in certain cases. The key is we don't expose those to the user. And the reason is that while they are composable, we can compose promises, we can compose observables, they still require the developer to think about the current state of their application. So these are really great APIs. Callbacks, promises, observables, they're really great APIs, and they do make asynchronous programming simpler. But with Relay and the declarative component-based architecture, we can actually eliminate a lot of those concerns. The same way React eliminated the problem of managing state in the DOM, Relay does the same thing for data fetching. So this, in a nutshell, is Relay. It's working really well for us for managing data in really complex applications. And as I mentioned, it allows the product developers to focus on their product. And this is not just hypothetical. We're using this in production apps. Relay was developed from the start alongside products to solve the hardest problems that those products were facing and make them easy. So we can't make hard problems disappear, but we can make hard problems go away, and we can make the common case really simple. So Relay was designed and built for the web, but it actually turned out to be so powerful on the web that we began using it for all of our data fetching inside React Native. So pretty much all of our React Native apps use Relay, to the point where I think there might be some developers who think that they're the same thing. Although, obviously, with talks like this, hopefully that'll go away. Again, just like React, Relay provides a consistent development experience across platforms. And a couple highlights, we're using Relay in the standalone Groups app for Facebook, as well as the standalone Ads Manager app. All the data fetching is powered by Relay. So, we were using Relay internally. It's been really successful for us. We're continuing to use it in more and more products. And it doesn't solve all the problems, right? There's still some things that we're exploring, but it does work really, really well. And we're looking forward to collaborating with the community on this. Obviously, we've gotten asked by a lot of people. We're planning to release Relay open source in August. And we really look forward to collaborating with all of you and to get your feedback as well. So thank you, and please ask questions later. Thanks. Thank you. I think I'm out of time, so just please find me afterwards. I'll be around and ask questions. Thank you so much.